Welcome to Maths and Science by IITIan channel. Now, in the last two lectures, we have discussed about the complex numbers. It is the fourth lecture. And in the last lecture especially, we have discussed about inequalities. Two inequalities we have observed. Now, the most important third inequality is modulus of z minus w is greater than or equal to absolute value of modulus of z minus modulus of w. This can be proved using the previous theorems in the last lecture. For clarity, please refer to the last lecture also. I am from Maths and Science by IITIan channel. Here what we are supposed to prove, modulus of z minus w is greater than or equal to absolute value of modulus of z minus modulus of w. This we have to prove, or we have to understand or analyze. Now, we know already that modulus of z plus w is less than or equal to modulus of z plus modulus of w. This is already discussed in the previous lecture. Using this, we will try to prove that modulus of z minus w is greater than or equal to absolute value of modulus of z minus modulus of w. Given this one, modulus of z plus w is less than or equal to absolute value of z plus absolute value of w. Modulus of z plus modulus of w. Then, can we write modulus of z is equal to modulus of z minus w, it is modulus of z minus w plus w. Here we have added only one w and subtracted it, so that modulus of z is as it is there. Then, as per the already proved theorem, modulus of z plus w is less than or equal to modulus of z plus modulus of w. Now, let me say this modulus of z minus w as some zeta. Then, modulus of zeta plus w is less than or equal to modulus of zeta plus modulus of w. From this one, this is equation 1, let us say. From this one, we say that modulus of zeta plus w is less than or equal to modulus of zeta plus modulus of w. This zeta is nothing but z minus w. Modulus of, replace zeta with z minus w. Because this is zeta, z minus w is zeta. That means modulus of z minus w plus W is less than or equal to modulus of Z minus W plus modulus of W. What is modulus of Z minus W plus W? The modulus of Z minus W plus W is, this value is modulus of Z. This implies modulus of Z is less than or equal to modulus of Z minus W plus modulus of W. That implies when you take Z to the W to the other hand side, left hand side will get modulus of Z minus modulus of W is less than or equal to modulus of Z minus W, which implies modulus of, when you change the sides in an inequality, the inequality also changes. A is greater than or equal to B implies B is less than or equal to A. Please remember this in inequality. Similarly, modulus of Z minus modulus of W is less than or equal to modulus of Z minus W. That's what we have proved here. Then by changing the sides, we'll get modulus of Z, we'll change the color of the pen. Modulus of Z minus W is greater than or equal to modulus of Z minus modulus of W. This is what we are supposed to prove. This whole will have a absolute value with it. This will have a absolute value with it. Whenever there are two complex numbers are added or subtracted, it is better to have absolute values in mind. That means ultimately we have proved that modulus of Z minus W is greater than or equal to modulus of absolute value of modulus of Z minus modulus of W, absolute value. Proved. And finally, in this lecture, I want to give the geometrical interpretation, because ultimately they are complex numbers, they are like vectors. I have already told you y is imaginary and x is real, and there is a point P1 here with x1, y1, and another is P2 here, x2, y2, and the resultant of this, what you call, this is O, this is P, this is O, 0, 0. I have already shown you in the first complex numbers initial introductory class, OP1 is equal to, the magnitude of the vector OP1 is equal to magnitude of the vector Z, complex number Z1. Z is equal to x plus iy. Z1 is equal to x1 plus iy1. Z2 is equal to x2 plus iy2. And modulus of OP2, the magnitude of OP2 is nothing but magnitude of Z2. That is magnitude of x1 plus iy1. This is nothing but magnitude of x2 plus iy2. Now, from the parallelogram, law of parallelogram for vectors, if you remember from your basic elementary mathematics, this point, the resultant of this vector and this vector. This vector is OP1, this vector is OP2. The resultant of both is at the coordinate x1 plus x2 and y1 plus y2. This let us say OP. The resultant is OP. Therefore, OP resultant is equal to x1 plus x2 plus I into y1 plus y2. This is what is from the parallelogram law of vectors. This is how a addition of complex numbers is there. And the addition of complex numbers is an addition of vectors. You please, I have already explained you in the previous class. This is what is the result, and from that result we made out three inequalities. The first inequality, first two inequalities are three inequalities, but only some books only deal with two inequalities. No problem. Z plus W is less than or equal to magnitude of Z plus magnitude of W. This is 1. Second inequality is same Z plus W is greater than or equal to absolute value of magnitude of Z plus magnitude of W. This is. Third inequality is just now we have derived and proved it. Z minus W is greater than or equal to magnitude of Z plus magnitude of W minus, sorry it's not, because it is minus sign is there, minus. In second one also we missed the minus sign. We will put it. Here it is minus. Even though it's obvious from the first one, some books make only these two inequalities. This is obvious. But still I have added and proved it in the previous class because I wanted a clarity. When you add two vectors, this is what is different scenario. These are the different scenario we come across, and the inequalities are like this. And with this, I want to conclude this session on inequalities. I am from Maths and Science by IITIan channel. If any value addition took place because of my videos to your knowledge, kindly share, view all my videos, view all videos, review, comment, and subscribe. I developed a playlist, Algebra by IITian. In that playlist, I will put the total number of videos till now made, and playlist link is provided in description. Thank you for viewing my channel. Thank you for viewing my video. Thank you for listening to me. Please try to prepare for yourselves in complex numbers. We have defined the complex numbers. We have done the addition. We have done the subtraction, and we have done the inequalities also. In the next class, we will be dealing with either some numericals, or we will be dealing with argument of the complex numbers, or we will do some geometry on the complex numbers. Thank you. Best of luck.